Hi, Doc Revis here with Watch Me Work It. Percent concentrations, percent mass, percent volume, percent mass volume. Let's start by showing you an example of all three. First, mass percent. What is the mass percent of a solution of 5.5 grams of table sugar in 20.5 grams of water? Mass percent works like any other percent problem, where we take the mass of the unknown or the species we're looking for over the total mass. And you have to remember that the total mass includes the species we're looking for. So in this case, it would be X grams over, you will always bring this value right down, plus the other mass in grams. Be aware that the units must match. You must have gram here, times 100 to convert it to percent. So in our case, this would be 5.5 grams over, bring this right down right away, 5.5 grams. You'll always see that line up, plus 20.5 gram times 100. And if we punch these numbers through to 2 sig figs, we'll get 21%. Let's do a volume. It is the same process. Okay, so but in this case, we have volume percent will equal the volume of what we're interested in over the total volume. And this should have said total gram. So total volume times 100 will equal to the X volume over, we'll bring this volume right down, X volume plus the other volume. So it has to be the total volume. Whether it does it in chemistry or not, if it's in the solution, it counts as a total volume. Times 100, so this would be 5.5 mils. In this case, it said, what is the volume percent of a solution of 5.5 mils of corn syrup in 30.5 mils of water? So they all match, and that works out really well. So now we can bring the 5.5 mils down, plus the 30.5 mils of water. It doesn't matter whether it's water or corn syrup. What matters is it's a volume times 100, and that's going to equal 15% when you run the numbers through to 2 sig figs. All right. So remember, volume, you have to look for all your volumes, and they have to be there. In the case of mass, you have grams, and as long as we have all grams, we're good. We simply do a division of the amount we're looking for divided by the total of those. Let's try one more where it's mass volume. In this case, it's going to be mixed. We have grams and we have mils of water. So we would take mass volume percent will equal to the mass that we're looking for divided by the total volume, which must include the volume of X as well. Not the mass of X, but the volume of X. So let's put the grams of X, which we already have, 4.5 grams of X. And that's going to be divided by the volume of X, which we don't exactly know yet, plus the volume of rest of the solution. Okay, in this case, it's a solvent. So we need to calculate the volume of X. And so the volume of X we could do two ways. One, if we use the density formula, we know that D equals mass over volume. So V equals mass divided by the density, which would be 4.5 grams divided by the density that I'll look up on the table. And we have table sugar at 1.59 grams per mil. So we have 4.5 grams divided by 1.9 gram per mil. And we can get that volume. It's going to be times 100 here. And we would have 4.5 grams So we would have 4.5 gram divided by this volume that we calculated through on the calculator. It's 2.8 mils. So this would be 2.8 mils plus 25.5 mils. Punch these numbers through on our calculator times 100. And if we punch these numbers through, we get 16%. Alternatively, to find this, we could have used dimensional analysis. And for dimensional analysis, we would say 4.5 grams times bar grams to mils. And this would be 1 mil for every 1.59 grams. And we would get the same number, 2.8 mils here. So that's how we work mass, volume, and mass volume calculations.